So the next logical progression from arithmetic sequences is to geometric sequences. The major difference between the two being that in geometric sequences, we have a common ratio between terms. Ratio is different than difference in that a ratio is a division. So if we look at term to term in this first example, we see a ratio of 54 over 18, which equals 3, and 162 over 54, which is also equal to 3. Thus, our ratio is 3. Likewise, we can see a little bit easier in this other term. From 10 to 5, there's a ratio of 2. From 20 to 10, there's a ratio of 2, etc., etc., etc. Now we're going to develop a method for finding an explicit formula for this geometric sequence. And we're going to use our common ratios to get us there. We see that in this sequence, we have a ratio of 2. So 5 is the first term, we know that. And then to get to my second term, a sub 2, that's equal to my first term times 1 ratio, or in other words, 2. Then in the second number that I move to, or my third term, I use my ratio and I multiply by 2 again. So I can either say that is 2 times 2, or I'm going to say 2 squared because it's going to help me a little bit more in this case. In the third number after the first, or my fourth term, I take my first term and I multiply by 2 again. So I'm raising it to another power, so 2 to the third. My fifth term, I take that first term and I multiply by the common ratio once again, thus going to the fourth power. So if I want my nth term, I take my first term and I must raise 2 to a specific power. Now once again, I want you to take a look at the subscripts and the powers. And you'll notice between the subscripts and the powers, there's always a difference of 1, the power being 1 less than the subscript. So if my subscript on the nth term is n, then the power must be 1 less than that. So in general, for a geometric sequence, I get my nth term, and the nth term is once again a value, is equal to my first term, a sub 1, times the ratio raised to the n minus 1 power. N is the number of terms, or the subscript. Once again. Again, this is a formula you're going to want to know. All of these early sequence equations are formula driven. If you know the formula, it's going to be hard to miss the problem. If you don't know the formula, you won't be able to get started. So if I have the third term with a ratio of 4 and I want to find the 20th term, what I feel most comfortable in doing is finding the first term. So I would say, well, if I know my third term has a value of 96, that's equal to my first term times the ratio, which is 4, raised to the subscript of that first number, minus 1. So that's 3 minus 1 power. So this gets me 4 squared, which is 16, times the first term is equal to 96. I divide 16 into 96, get 6. That gives me my first term. Now I'm going to do a second equation and say I'd like to find my 20th term. That's going to equal my first term, which is 6, times my ratio, which I know is 4 since that gets given to us, times the subscript, or raised to the subscript, which is 20 minus 1. So this is going to be a rather large, so large that it goes to scientific notation. So the 20th term is equal to roughly 1.64 times 10 to the 12th power. So now we're going to write an explicit formula for this term here. Unlike our explicit formula for arithmetics, I need some a sub n equaling a1 r to the n minus 1 power. And what I'm going to want to solve for is the first term and the ratio. Well, luckily, in this case, I see my first term is 160. I see my ratio from turn to turn, well, to get from 160 to 80, I go 80 over 160. Check to make sure that's the same as 40 over 80. Surely enough, it is. That reduces to a half, and that's my ratio. So I say that's 160 times 1 half to the n minus 1 power, and that's equal to my nth term. This is my explicit formula. To prove that, I'm going to take and find, let's say, the 5th term. So if I want to find a sub 5, I should be able to plug that subscript 5 into this equation and get out the number 10. So I have 160 times 1 half raised to the subscript is 5 minus 1. So a sub 5 equals 160, a half to the 4th, which is 160 times 1 over 16, which gives me a 5th term equivalent to 10. So sure enough, it worked. So the boxed answer right here is my explicit formula. So in this next example, we see we have to find 3 geometric means between 6 and 96. So our non-consecutive terms are 6 and 96. And then there's 3 unknowns between them. All we need to do is find the ratio in this geometric sequence, multiply that by 6 3 times, and we should end up at 96. So let's move through. We know 6 is our first term once again. 96 is our 5th term. Therefore, 96 equals our first term 6 times our ratio to the subscript, which is 5 minus 1. 96 divided by 6 is 16. That's equal to r to the 4th power. So we'll take the 4th root of each side. Fourth root of r to the 4th is just r. And the 4th root of 16 could actually be plus or minus 2. So therefore, if I multiply plus or minus 2 by 6, I get 12. And it could be a positive 12 or a negative 12. Then if I were to multiply plus or minus 2 by 12, I get 24, followed by 48, followed by 96. And these would, in theory, all be plus or minus, and they could alternate. So let's say they were positive. If they were positive, then 12, 24, 48. If I was multiplying a negative, I get a negative 12. Negative times negative 2 is positive 24, negative 48, and then a positive 96. So either way, I end up with positive 96 in the end. So here we have our first term and our 4th term. we're looking for our 10th term. I'm going to need to find my ratio, so I know my 4th term is 20. My first term is 2. This is geometric, so this is r to the 4 minus 1. We end up with 10 is equal to r to the 3rd. So the cube root of 10 is equal to my ratio. And now I'm looking for my 10th term. So a sub 10 is equal to my first term, which is 2, times the ratio cube root of 10 raised to the 10 minus 1 power. So I've got 2 cube roots of 10 to the 9th. Clean that up a little bit. That's 2, 10 to the 1/3 power raised to the 9th, which goes to 2 times 10 cubed, or 2,000. Here are the questions for the day. Put them on the forum and we'll talk about this tomorrow. Thanks.